Alright, love this question from 2016, Further Maths Exam 2. This was in the financial module, and it was question 7, which was the last question in the module. The state did particularly badly in question 7, and in particular part B. So we're going to have a good look at this question and see if we can, nut it out and really understand what's going on with it. Okay, so Ken has borrowed $70,000 to buy a new caravan. Charged interest at the rate of 6.9% per annum, compounding monthly. That's important, the monthly compounds. For the first year or 12 months, Ken will make monthly repayments of $800. Find out the amount Ken will owe on his loan after he's made 12 repayments. Alright, so there's no question for me, this is financial solver, so let's get into it. So we're going to go menu and finance and financial solver. Alright, N is the number of periods or number of payments, so that's 12. Okay, 12 repayments. I is interest, that's 6.9%. Present value of the loan. Okay, let's just make sure we get our sign convention right here. Now remember, we use this sign convention here. It's positive when the bank gives us money. It's negative when we give the bank money. Okay, so bank money coming to us, positive. Money going away from us, negative. Alright, so that means the present value of the loan is $70,000, and the bank gives us that money to spend on the new caravan, so that's positive. Alright, our payments, they go back to the bank from us, so that's negative, $800. And what we'll do is flick the PPY and CPY values to 12 and 12, that's payments per year, and compounds per year. Okay, and what we want to get is the future value here. So this is saying it's negative 65,076. Now basically that means that we would need to give the bank $65,076.22 after 12 repayments. Okay, so we forget the negative sign, we don't include that in our answer, and we just say that it is $65,076.22. And that was all you needed for the 1 mark there. Okay, so virtually half the state couldn't do that question. 1 in 2 students didn't know how to do that, and that's a, it's a fairly simple sort of financial solver problem. There's no condition change, nothing. All right, what is the total interest that Ken will have paid after 12 repayments? Well, basically, if you really couldn't do this one here, you were going to struggle with this. So what we can see is we've dumped a further 20% of the state here. Virtually in this particular question here, only 26% of the state got this right. So what we're going to do here is basically work out how much I've paid in repayments in total. Okay, so 12 lots of $800 is $9,600. Okay, and what we're going to do is add that amount here to the current status of the loan after 12 repayments. Okay, so essentially what we owe on the loan is $65,076.22, and I'm going to add all of my payments back onto that. Why? Well, I'll show you in a sec. So let's go over to the calculator, we hit escape to get out of financial solver, and let's do $65,076.22 plus 9,600, so plus the payments. And what we get is $74,676.02. That should be 22, and this brings up a really interesting problem here. So what we're going to make sure we've got is we want to have, to do this question here and to get the rounding right, we want to be in float on this TI calculator. So what this means is my calculator is in float 6 at the moment. Okay, now that will decrease the precision of our answers, and I'm sure this is going to affect a question this year. So let's just double check and see what's happening here. So go to settings and doc settings, and sure enough I'm in float 6. So let's drop it into float and make that the default. Okay. Now remember, every time you reset your calculator, I think you have to reset the float. So it's worth checking anyway. Absolutely, before an exam, you'd want to check this. Alright, now I'm going to hit enter again, and it's got the correct rounding this time. Okay. So what we're going to do is we'll show our working for this. We've got $65,076.22 plus 9,600 equals $74,676.22. Now what we're going to do is actually remove the amount we borrowed off this amount here, okay? Because this is what we owe, this is what we've paid off, okay? And if I remove the actual value of the loan, what will be left over in the end is the interest repayments, okay? So 74676.22 take away 70,000, 4676.22 in interest. So yeah, pretty hard question there, but not that dissimilar for a lot of than a lot of the questions in the Cambridge about interest. So you would use the same strategy. All right. So here's the big one. So 8% of the state got this one right. Okay. So it's a tricky problem. So let's have a really good think about this. So after 3 years, Ken will make a lump sum repayment or payment. Now remember, a lump sum payment is an amount above the standard repayments, and what it's going to do is take off more of the loan than would be the case if I'm paying off just the $800 a month. Okay, usually the lump sum payment is something that's like, you've inherited some money or you've come into some money for whatever reason, and you want to knock down any loans as quickly as possible. So after 3 years, Ken will make a lump sum repayment of L dollars in order to reduce the balance of his loan. This lump sum payment will ensure that Ken's loan is fully repaid in a further 3 years. So what we're noting is that this is going to be a 6-year loan. Ken's repayment still remains at $800 a month, and the interest rate remains at 6.9, compounding monthly. So we're looking for the value of Ken's lump sum payment, and we want to round it to the nearest dollar. Okay, so let's go back over to the calc and go back into Financial Solver. Alright, and this time we've got a different end period. Alright, we've got 3 lots of 12 or 36 payments over the 3 years. Alright, oops, let's change that. 36. Oh, why isn't that changing? 36. 6.9. The present value is what we borrowed. Payments are 800. Let's hit enter here. And what that is saying, basically, at the end of 3 years or 36 installments, paying off 800 a month on a loan that's worth 70,000, I'll basically owe 54,000. So let's write this down. 151.60 after 3 years. Now, essentially, what I want to do then is reduce this amount. So here's where Ken pays his lump sum. Alright, so this amount here is going to be reduced by an unknown amount, and then the remainder is going to be paid off in 3 years. Okay, so essentially I need to then work out what amount it's going to go down by. Okay, and really this is something that Financial Solver really won't do unless you understand what and how this program works. Okay, this software works. So how are we going to do it? Okay, well, let's consider the value of our loan at the end of 6 years. That is, after it's been repaid in a further 3 years. What's the future value going to be? And I know that's going to be 0. My payments are still $800. Okay, and I've got 36 lots of payments. Why don't I click here on present value and see what the value of the loan would be if we basically pull back from 0, and it's almost like going in reverse. Okay, what it's going to do is pull us back to what the value of the loan will be that I can pay off with payments of $800, 36 payments thereof, at 6.9% per annum. Okay, so let's pull back. And what we find is that the payments, or what I will borrow, what I will be able to pay back with this situation is $25,947.58. Okay, so that's the magnitude of the loan that I'll be able to pay off in 36 installments, $800 a month. Okay, so let's think about this. So 25,947.58 will get me to, well, not me, but Ken, to $0. Okay, in 3 years. So what we note here is this needs to be knocked down to this amount here. Okay, so here's our lump sum, and what we need to do is reduce this amount to this amount, and you can see fairly easily now, I think, that if I go 54,151.60, take away 25,947.58, I will get the value of my lump sum payment. So let's go into our calculator and do it. 54,151.60 subtract 25,947.58. So the lump sum payment has to be $28,204.02. So what we'll do is we'll finalise our answer because we need to round it to the nearest dollar. So Ken's lump sum is 28,204. Okay. Alright, so pretty tricky question there, and yeah, if you got that one right, you're doing alright because you've knocked out virtually the whole state who couldn't do that question.